In the formula A equals LW, A is the subject of the formula. If we want to make W the subject, we could simply divide through by L, which would give us A over L equals W. Now, in order to make a letter the subject of a formula, we rearrange by performing the opposite operation on each letter you wish to move, until you have the required letter on its own. Now, some of these changing the subject of a formula questions can be really difficult, so we're going to start off nice and easy and then build up to the harder questions. The first one we're going to rearrange is this one here, y equals 2x minus 1. And we're going to make x the subject of this formula. So if we take a look at the side that the x is on, we need to get rid of all of those things around x and get x on its own. So the first thing I'm going to do is get rid of this minus 1. How do I get rid of minus 1? If I do the opposite, I add 1. So adding 1 to both sides gives me y plus 1 equals 2x. So remember, all I've done to both sides is to add 1. How do I get rid of that 2? Well, think about what's being done. Here is 2 multiplied by x. So the opposite operation of multiplying is dividing. So if I divide by 2, remembering to do it to both sides, I will be left with x on that side. And careful how you write this, because it's all of this that's being divided by 2. So I've now rearranged my formula and made x the subject, and it's equal to y plus 1 over 2. Okay, so moving on, we've seen this formula earlier on. It's the velocity formula. V equals u plus at. In this particular example, it asks us to make t the subject of the formula. So let's look back here. Now, the first thing I want to do is to get rid of this u. Remember, it's always those things that are furthest away from the t that were done last. So essentially, they're the things we get rid of first. So in order to get rid of this u, I'm going to subtract u from both sides. That will leave me with at on the right-hand side and v minus u on the left. Now, if I want t on its own, a multiplied by t is what's happening here. So in order to get rid of that a, I need to divide, and it would leave me with v minus u over a. So all we do to rearrange any of these formulae is to just do the opposite operation to what's being done in the question when we see it. Moving on. In this question, we're going to make a the subject of the formula, and it's c equals a minus e over 4. So let's take a look at what we need to get rid of first. Before we can do anything here at the top, we need to get rid of that divide by 4. The opposite of dividing by 4 is multiplying by 4. So both sides get multiplied by 4 to give me 4c equals a minus e. Almost there. I want to get a as the subject, so I need to get rid of that minus e. So I'm going to add e to both sides. That will give me 4c plus e here, and a there on the right-hand side on its own. Remember, again, it doesn't matter which side of the equal sign your letter is on, so long as it's there on its own. Okay, so let's carry on. More complicated example this time, but the process is exactly the same. My formula this time is t equals 2 pi multiplied by the square root of L over G. And I want to make L the subject of this formula. Now, let's look at what I need to get rid of first then. Well, that square root sign is obviously keeping control of those, and that 2 pi would have been the last thing that was done, so it needs to be the first thing I get rid of here. 2 pi multiplied by that means I need to divide in order to get rid of it. leaving me with, when I've divided this side by 2 pi, and when I've divided by 2 pi here, don't forget, it's to get rid of it off of that side so it disappears. Okay, so remember, when you divide by something like this, you don't have to divide by the 2 and then the pi. You can divide by 2 pi altogether. Anything being multiplied together can also be divided over at the same time. Now, let's get rid of this square root now so I can get into the L over G. The opposite of a square root is to square. So I'm going to square each side. Now, be careful when you square the left-hand side here. T squared, obviously we write like this, but remember all of this on the denominator is being squared, so each part will get squared. 2 squared is 4, and pi squared, I would write like that. By squaring each term individually, it avoids the need to put in any brackets. Now remember, when I've squared this side, all I'm going to be left with is my L over G. So I'm almost there now. I want to get L on its own. The last thing I have to do is to get rid of that divide by G. Opposite of dividing by G is multiplying by G, which when I do to both sides, that will leave me with L on that side, which is what I want, will give me GT squared over 4 pi squared. Remembering that when we multiply a fraction by something, it goes to the top, so it's GT squared as our numerator and 4 pi squared as our denominator. Now that is a much more complicated question, but remember the way we worked it out was still the same. We looked at what operation was being done and then we did the reverse in order to get rid of it. So continuing on with these slightly more complicated rearrangements, our next one is using this formula here. 1 over A equals 1 over B plus 1 over C. And they'd like us to make A the subject of the formula. Now, at the moment, it's not the subject of the formula because it's 1 over the letter. And unfortunately, it's not as simple as just flipping all of the fractions to make A equal to B plus C. Again, the systematic approach here is going to be very useful for us. So, first of all then, we need to get rid of all of these denominators. So the first thing we're going to do is to multiply everything by A. That's going to leave me with just 1 on this side. Remembering everything always goes to the top when we multiply a fraction by a quantity, so it would be A over B plus A over C. Again, multiplying again to get rid of one of those denominators, I'm going to multiply by B this time. That's going to give me B on this side equals A plus AB over C. So you can see bit by bit we're getting rid of those denominators on the fractions, and then once we've got rid of them we can rearrange and make A the subject. So last thing we're going to do then, to get rid of this C on the denominator here, multiply by C. That will give me BC equals AC plus AB. So I've now got rid of all the denominators, so no more fractions, and I can now see my 2 terms that contain the A, and I'm going to use that now to help rearrange the subject. But there's a very quick way of making those 2 letters just 1, and that is by factorising the terms that contain the letter you want. So if we look back here, my 2 terms are AC and AB, but I can factorise that to give me A lots of C plus B. And you can now see that instead of having 2 terms with an A in them, I've now just got A there on its own outside the bracket. This side hasn't changed, it's still BC, but it's now much easier for me to make A the subject because all I need to do is to divide by that bracket C plus B. I can divide it all over at once and that would leave me with A there equals BC divided by C plus B. So if we take a look again and see the steps we went through, the first thing we did was we had to get rid of each denominator. So that in itself was 3 calculations. And then once we got rid of the denominators, it was easy to see that if we factorised that expression, we could then get A on its own, and we just divided by what was contained in the bracket. You could write the brackets down here or not, it doesn't matter because you're showing you're dividing by that entire amount. So here's an example where factorisation helps you to rearrange the subject of the formula. Now the last one we'll look at is another one where factorisation will help us. The formula up here is A equals 2xy plus 2xz plus 2yz, and they would like us to make y the subject of the formula. So if we have our formula here, you'll see that one of the terms in it, this one here, doesn't contain y at all. So I can take that over the other side straight away and then just leave myself with the terms that contain y on the right-hand side. So subtracting 2xz from both sides will give me a minus 2xz equals 2xy plus 2yz. Now, exactly as we did before, take y out as a factor on that right-hand side. That will give us y lots of 2x plus 2z. Don't forget the left-hand side stayed as it is. We haven't done anything to that yet. And then the final thing we're going to do, just as we did before, divide by that whole bracket to leave me with y on this side. That would be a minus 2xz, all divided by 2x plus 2z. Now don't be tempted here to try and cancel out all the 2's, because remember this term hasn't got a 2 there, so we can't divide everything by 2. We just leave that as it is.